So, although we recognized that this was going to be controversial, we really thought it was a very interesting finding.
Science magazine sought out the opinions of other experts in the field. And although their comments were not all favourable, Don Kennedy decided that on balance, this remarkable paper was good enough to print.
We felt really comfortable about going on with the paper, comfortable in the sense that it was solid work from a very good laboratory by good people, and it would have to then endure the test.
So on the 8th of March 2002, Russi Talyakin received the endorsement of America's most prestigious scientific journal, and his fusion results were published in Science magazine. And immediately ran into a storm of criticism. That serious flaws had somehow been overlooked.
Said we were dealing with
things in the article didn't seem quite right.
Fusion found this paper unready for publication.
Less than.
Ultimately, many scientists felt the paper should never have been published at all.
Extraordinary claims require extraordinary proof.
Fusion research is a heavily contested field, both because there are reputations to be made and because the amount of federal dollars spent on it is quite large, and people want their share of that research support. So don't ever expect this to be a peaceful domain in science. It's not going to be.
The criticism focused on one crucial issue, the same issue that cold fusion had foundered on: neutron detection. The best way to check if fusion was happening was to detect neutrons, the tiny particles that are given off when atoms fuse together. But there was one major complicating factor. Russi Talyakin was also using neutrons in his experiment. The small bubbles that led to his breakthrough were created with a device called a pulse neutron generator, which fired out over 1 million neutrons a second. And sorting out these background neutrons from any created by a small fusion experiment, although possible, was no easy task. Some scientists suspected that Russi Talyakin's fusion neutrons could in fact be coming from his own neutron generator, bouncing around the room and then entering the neutron detector, where they were mistaken for evidence of fusion. Russi Talyakin had an answer. He had conducted several control experiments to rule out the influence of background neutrons. But even in Oak Ridge, there was a conflict over his work. The management of the laboratory was sufficiently concerned about Russi Talyakin's fusion claim to ask someone else to double-check it.
And now we'll count for another 2 minutes and see how many we got.
They called in Mike Saltmarsh, an expert neutron hunter with over 30 years' experience of neutron detection and fusion.
42,043 neutrons. 42884. The reason I was asked to look at it is actually I hate to sound immodest, but I'm rather a good experimental physicist, and I do bring a background in neutron detection.
Mike Saltmarsh's task was to work out whether the neutrons detected could indeed be from fusion or were simply background neutrons from the neutron generator.
There is always a background, some of it due to natural background radiation. In the case of this experiment, there was an additional enormous background from the neutron generator itself, which was producing 1 million neutrons a second that were going all over the place. And consequently, any neutron detector has to be able to sort out whether the neutrons it's seeing are from that or from something else.
The way to do it was to run the experiment again in Russi Taliakin's laboratory, where Mike Saltmarsh could measure the neutron background, take it into account, and then concentrate on finding fusion neutrons over and above that. So he took a neutron detector, set it up, and after extensive testing, he found no evidence of fusion.
If there had been fusion going on at the sort of rate that Taliakin's paper was claiming, we should have seen an enormous increase in the neutron detection. And we didn't.
Instead, Mike Saltmarsh thought that any fusion finding could be explained by the background neutrons from the pulse neutron generator. So he wrote up his report. And a couple of months after Russi Taliakin's paper, this was also published. It was a damning conclusion. Russi Taliakin and his team disputed Mike Saltmarsh's conclusion. But for the next 2 years, there was a steady stream of criticism.
There's been many a day that I come home dejected, desperate. But not until somebody really goes through trials and tribulations like of that type, being called all kinds of things, nasty things, it shakes your self-confidence and your value as a human being sometimes.
Eventually, he decided to try again. So he designed a new experiment with better neutron detection. And after months of checking and confirming, the results were ready. This time, the neutron signal was even stronger. And he was convinced it simply had to be from fusion.
Now there is very, very, very little or absolutely no chance that these neutrons could be confused as having come from the pulse neutron generator.
So he sent these results to Physical Review E, a highly respected journal. And after an extraordinarily thorough review, they were accepted for publication.
Look, everything we've gone through, all the trials and tribulations and the gut-wrenching feelings that you could be wrong and you might be making a fool of yourself on the world stage, you feel like, I guess you've been, what's the right word, vindicated.
But despite this second publication, many skeptics still weren't convinced. They believed that there was one vital measurement that still hadn't been made. It was a measurement that could finally prove once and for all whether Russi Taliakin's neutrons really were from fusion. It was all to do with timing. If fusion was taking place, neutrons should be recorded at the very moment the flash of light was given off. The flash of light would be recorded like this, and the neutron would be recorded at exactly the same time like this. But there was a complication. Sonoluminescence light flashes are incredibly fast. Each flash lasts just a nanosecond, 1/1000th of a second. And if fusion was happening, then any fusion neutrons should be produced at exactly the same billionth of a second. and should be recorded like this, together. But Russi Talyakin's instruments could not measure with nanosecond accuracy. They measured over a much longer timescale, which meant that stray background neutrons recorded sometime after the flash of light, here, or here, or here, could still be mistaken for signs of fusion. So to convince the skeptics that fusion really was happening, the burst of neutrons had to be recorded in the same billionth of a second. If not, they wouldn't be convinced that it really was fusion.
Unfortunately, this particular measurement, which is within the capability of modern technology, has not been presented in either the first paper which appeared in Science magazine or in a follow-up paper.
Russi Talyakin believes that he has repeatedly detected neutrons at the same time as flashes of light, and that he has already proven his claim beyond a doubt.
My lab has been audited. My instruments have been audited, and my books have been audited. The data speak for themselves. The data have to speak for themselves, and it's difficult. It's difficult to, I mean, how can I answer that I know absolutely 100% sure that it is what I think it is? I just have to look at the data, and the data have been looked at very carefully. In the history of publications, I probably will not be able to find one that has gone through this level of scrutiny. If you do, let me know.
If he's right, a great discovery has already been made. But if he's wrong, his reputation could be severely damaged. The dream of a shortcut to nuclear fusion hangs in the balance.